So we just calculated this as our log likelihood of the Pareto distribution, right? The log likelihood was n log theta plus minus theta minus 1 times the sum of the logs. And the MLE we found after maximizing this function was n over the sum of the logs. And the Fisher information is 1 over theta squared. Okay, so if we want to do Wald's test on the Pareto distribution, remember, Wald's test is just equal to n times the Fisher information at the MLE, right? So the Fisher information at the MLE is just 1 over theta hat MLE squared times the MLE minus the parameter we want to test against, right? So in this case, it's theta naught. Right? And under the null hypothesis, right, when theta naught is actually the true parameter, right, Wald's test tells us that this converges in distribution to chi squared 1, right? And this is, again, under h naught. Okay? So this means that if this, sorry, there's a square here, right? We need the square of a normal. So what this says is that if this quantity is very, very large, it would have low probability of having been generated by a chi-squared distribution. Remember that a chi-squared distribution is always positive, and it sort of looks like this, where there's a peak closer to 0, but as you go off to infinity, it goes off to 0. So our test in this case will be to reject the null hypothesis when this statistic is large. So let's call this Tn, right, to show that we're going to calculate it from our n samples of data, x1 to xn. And our test is just going to be to reject when Tn is greater than or equal to some quantile of a chi-squared 1. Okay, so let's say in this problem we want to test at a level of 0.05, right? So basically what that means is under the null hypothesis, we want a probability of 0.05 of actually rejecting the null hypothesis, right? So under the null hypothesis means that the null hypothesis is true. So what that means is we have a probability of 0.05 of making a type 1 error. So what this means is we want, basically, the tail probability of the chi-squared 1 to be 0.05. Here, this quantity that I wrote is the basically 1 minus 0.05 quantile of a chi-squared 1. Okay, and you can look this up in a table or use some software like R to actually calculate this. And you'll find that it actually equals 3.84. Now remember the likelihood ratio test. Right, has the form 2 times the likelihood of the MLE minus the likelihood of the null hypothesis value. And again, this converges in distribution under the null hypothesis to a chi-squared 1 distribution, right? Again, under h naught. So given that h naught is true and data is generated from h naught, this converges to a chi-squared 1. Okay, so again, this will be our statistic. Let's call this one Tn prime. And our test is just going to be the same thing that we had here. Basically, our test in the likelihood ratio case will be to reject when now this statistic Tn prime is greater than or equal to the tail, again, the tail quantile of a chi-squared 1 distribution. So again, if we want to have a test at level 0.05, we look at this quantile. Okay? Now, these are the general tests. In the next part, we're going to actually plug in these values and see what these two tests give us.